All right, let's get right into it. If you've ever wondered what it actually takes to build machine learning that works in the real world, not just in a lab, then you are in exactly the right place. We're going to break down the big ideas from Chip Huon's amazing book, Designing Machine Learning Systems, and see why building this stuff is so much more than just training an algorithm.
So you've probably heard this phrase thrown around, right? Software 2.0. It's this cool idea that, instead of a programmer writing every single rule by hand, we can just feed a machine a mountain of data and let it figure things out on its own. Sounds pretty straightforward, doesn't it?
Well, as you might have guessed, not quite. The concept might be simple, but putting it into practice, that's where things get messy and fast. This is the huge gap between a cool side project and a real production-grade system that millions of people might depend on.
And this, right here, is the core lesson of the whole thing. Chip Huon says that whenever people ask her for the secret to building a great ML system, her answer is always the same. It depends. It depends on your business, your budget, your users, your data. There's no magic formula, just a whole series of careful choices and trade-offs.
So, here's our roadmap for today. We're going to explore what those trade-offs look like. We'll start with why we need to think beyond the algorithm, then talk about framing the actual business problem, the all-important role of data, what happens after you launch, and finally, how this all comes together into one big repeating cycle. First things first, we got to get this core idea down. When we're talking about machine learning in the wild, we are not just talking about one clever model. We're talking about an entire system. In old school software, there was this sacred rule: keep your code and your data separate. But with machine learning, that wall just crumbles. Your data isn't just something the code processes. The data literally shapes the code's behavior. They're all tangled together: the code, the data, and the models that come from them.
Okay, so if it's a whole system, where on earth do you start? Well, not with the code. You start with the problem. And a real-world problem is never just a simple technical challenge. It's this messy knot of competing goals from all sorts of different people.
And this example is just perfect. Imagine you're building a food delivery app. Your ML engineers are all excited saying, let's use this massive, super complex model to get the absolute best recommendations. Then, the product manager steps in and says, whoa, hold on. If that takes more than 100 milliseconds, people will close the app. It has to be blazing fast. And just then, the business lead walks in and says, guys, that fancy model needs hardware that costs a fortune. Can't we get something almost as good for a fraction of the price? See? Everyone has a valid point. The final system has to balance all of them.
This is why you have to be crystal clear about what you're really trying to achieve. That's what objective functions are all about. You have to ask, what does success even mean for us? Is it getting the most clicks, making the most money, or maybe making sure our recommendations are fair and don't leave anyone out? Most of the time, it's a mix, and you've got to decide how to weigh each goal.
All right, so you've got your objectives figured out. Now you need the fuel for your engine, data. And let me tell you, data is the best and worst thing about machine learning. It's where all the magic comes from, but it's also, honestly, the source of about 99% of the headaches.
Let's just go ahead and bust a huge myth right now. In school, you might get these beautiful, pristine data sets where everything is perfectly labeled. In the real world, forget about it. Most companies start with the messy data they're already collecting anyway. Server logs, clicks, purchases. It's what they have.
And get this survey Chip Huon ran really drives the point home. Almost 2/3 of companies are relying on what are called natural labels. They're not hiring armies of people to label things. They're just using the signals that are already there.
So what is a natural label? It's pretty much what it sounds like. A user clicks on a link. They add something to their shopping cart. They share a photo. These are all natural behaviors we can use as labels. A click can stand in for, this was a good recommendation. It's awesome because it's free and you get tons of it, but it's also noisy. Maybe the user clicked by accident.
Here's another classic data nightmare: class imbalance. Think about building a system to spot credit card fraud. Now, hopefully, only a tiny fraction of transactions are fraudulent, maybe 0.1%. So if your model just learns to say, not fraud, every single time, it'll be 99.9% accurate and completely useless.
So what do? Well, here are two common tricks. On the one hand, you can do what's called undersampling, where you just throw out a bunch of the common, not fraud examples to even things out. Or you can do oversampling, where you make copies of the rare fraud examples you do have. Both have their pros and cons, but they are essential tools for dealing with the reality of messy data.
Okay, so you framed your problem, wrestled with your data, and trained a model. You push it live. Time to celebrate, right?
Nope, not even close. A deployed model isn't some statue you put on a pedestal. It's a living system that needs to be watched and cared for constantly.
And that care is called monitoring. As you can see here, you don't just watch one metric. You're watching a whole spectrum of signals. Way at one end, you're looking at the raw data coming in. All the way at the other end, you're tracking the big business goals, like accuracy. A problem could pop up anywhere along that chain.
And why is all this monitoring so critical? Well, one of the biggest culprits is something called data distribution shift. The world doesn't stand still, right? People's tastes change, new trends pop up, maybe your company launches a new product. The data your model sees today might look totally different from the data you trained it on 6 months ago. When that happens, its performance quietly starts to get worse and worse. We call this model decay.
And that brings us to the final crucial piece of this whole puzzle. All these different stages, the planning, the data, the training, the monitoring, they aren't a one-way street. They're all part of a big, continuous loop.
Here it is, the whole life cycle laid out. You frame the problem, you get your data ready, you train your models, you push to production, and then you monitor. But the most important step is number 6, iterate. Based on what you see happening in the real world, you loop all the way back to the beginning. Maybe you redefine the problem, get new data, and retrain the model. It's a cycle that never really ends.
And this quote from Goku Mohandas just nails it. The world of ML tools and techniques can feel totally chaotic. Without a disciplined approach that looks at the whole end-to-end system, it's so easy to get lost. Thinking this way is your map and your compass through all that chaos.
So we see that building these systems is complex, it's iterative, it's a huge technical challenge. We're getting really, really good at it. But that leaves us with one last and maybe the most important question. We know how to build powerful ML systems, but are we building responsible ones? That's the question that will define the next chapter of machine learning.